Hey, this is Barry with Outback Foundry. I wanted to do a little video on my Burnout kiln. I put this thing together maybe 3 years ago and have been using it steadily for a year and a half, and for the most part it's worked incredibly well. I started out the base of it, the channel base where the two forklift slots are, was from an old stationary electric air compressor. I believe it was a 50 horsepower electric air compressor that died, and it was going to the scrap iron bin, and I got a lot of pieces parts off of it, but pretty much that bottom channel is directly from the air compressor frame. The square tubing, which is some pretty nice stuff that I made the exoskeleton with, came from a diesel water pump, also from work, also that died, that was going in the scrap iron bin, and I kept the frame and cut it up, and I've been using little pieces of that tubing for ever since. I don't have much left, but I made the frame out of that tubing. The box is pretty much just welded sheet metal. It came from a oil storage tank that was here on this property when I bought this old building. It used to be an automobile repair facility, so they had this old tank in the back, which I cut up, and I've used all the pieces parts. It's got I made a hood. I don't know how well that'll show up. I made a hood out of sheet metal, and originally I had a fan in the duct that went out the back. I'm gonna move the camera. But after burning up 3 fan motors in a row, I've realized that it's just too hot to have an inline fan motor. So I took the motor out, just ran straight duct out the back of the building, and been pretty happy with it. It's keeping all the black soot from my ceiling in here. The ceiling's still clean. I've climbed around up in there doing repairs, and there's no black soot on the framing or the sheet metal. So the hood without a fan motor is doing great. I have 2 burners, one on each side. They're kind of at opposite corners. At first, when I first put the burner, I had it up high, thinking I should have one high and one low. Well, that was a mistake, because the heat kind of stays up near the top. So I moved this burner down lower, and much better. Kept the pipe on the top, and now it's a little peephole, so I can take a peek in there for whatever that's worth. The burners are Harbor Freight weed burners. I'll drill the orifice, because I run on natural gas here, not propane, and I drilled a hole in the side of the burner so I can light it with from the outside. I don't have to open the kiln to light it. There's just a little hole where I put a a flame under the bottom of that tubing, and it'll light the burner. So they've worked very well. I have 2 pyrometers I picked up from eBay for like $. They were extremely cheap, and they work great. There's a discrepancy from one side to the other of about 50 degrees, but for the most part, that doesn't make any difference. We're talking order of magnitude here. I put the white insulation between the pyrometer and the welded steel part of the support, because it was getting kind of hot, and I didn't figure that was good for the little printed circuit boards that are in there. But they've been very good. They've worked great. The way I'm set up is I light the burners, both burners, from the outside. I let it get up to about 1300 degrees, and then I open the bottom doors, which I'll show. Open the front door, and I put the molds in, and the wax will get hot and start melting, and it will run and drip into this stainless steel pan, which used to be a sewer holding tank in my boat. But anyway, I've cut it in half. That's my pan, and the wax falls on water, and that puts out the flame, because it's usually burning, and it also keeps the wax from sticking to the pan. And I reclaim, got to be close to 90% of my wax. It's worked very, very good. When I built the kiln, the idea was that that steel tray could slide out on these angles. Didn't work. Steel expands and twists and gets stuck every single time. So after trying that for a few times, I kind of gave up, and I thought, well, I'll just stick my head in there and grab the molds, and got a suit from a friend of mine who's a fireman, and that's no good. Sticking your head in there is no good. Burning up face masks, and it's just not safe. So then I built the tongs, the big tongs that hang from the ceiling, and I have a video on those, and they've been really good. So the tray does not slide in and out. Now, the door was built to go up and down and not swing sideways because of the angles that would support the sliding tray. Since I no longer need the angles, since the tray is not going to slide, in hindsight, I would have built a swing door. It would have been simpler, less complications. I wouldn't need the counterweights and all that stuff. So just a note, if you're getting ready to build one, I think a swing door is the way to go. Okay, I want to show you my detail of the doors. Since the ceramic fiber insulation, it's not very durable. It'll take fire forever and a day, but you can't like rub on it. You can't move it. It comes apart. So with the door sliding up and down, I didn't want the door to wear the ceramic insulation away. So I made it where the door kind of slides out away from the insulation and then swings in at the last moment, and I'll show you how it operates. The little bearings are riding on this curve, so right when it's almost closed, it swings in, and then when you want to open it, it swings out. And that's the same top and bottom, and it's worked pretty good. You can see the insulation's wearing a little bit, but still, you know, no flames coming out, no heat's coming out. It's doing its job. I'm not going to mess with the door, but if I had to do it over again, it's not tall enough. A lot of my molds do not fit under the door when I'm trying to put them in, so you have to kind of turn them sideways to get them under the door. So could have done better on that design. The door could have been, the opening could have been a little higher, and that would have been much easier with a swing door than a vertical door. But for this to work, I have the floor of the kiln is grating so that the wax can drip through, and at the moment that is my weak point. So I'm going to show you how the doors work. I'm going to open them up. I'll do that from a couple of different angles. So now the doors are vertical on the bottom, and that's important. The first time I had a burnout, I didn't latch the top latch, and they were hanging. I'll show you. They were hanging like so, which let the burning wax drip onto the door and spread fire, and there was fire everywhere. It caught the wax floating on the water on fire, and it caught the wax inside on fire, and the fire was shooting out the chimney on the top, and it was almost where I was going to get the water hose and go after it with the water hose, but it finally burned itself out. But if I remember, and I remember now to latch that door so it's in a vertical position, that problem doesn't happen. The wax drips into the water without falling on that door. The weak link I have right now in the furnace is the grating. The grating holds the molds and it allows the wax to drip through, but it can't take the heat. It has warped, and I've straightened it, and it's warped again, and I've straightened it again, and then I've welded those stainless steel bands around it, and the welds have broken loose, and it's warped again, and it makes it where you can't really, it's hard to stand the molds up because they want to fall over, and that's not a good deal. So I'm getting ready, and you can see these little these vertical steel on the inside against the ceramic insulation blanket. These were like 1/2 inch thick by 1 inch thick pieces of steel. These were pretty substantial, but the heat is taking its toll. Now they look like pretzels. The wire mesh that used to be welded on them is totally gone. So they're gonna go. I'm gonna get rid of this floor, this metal floor, and cast one out of refractory, and with enough holes in it, hopefully that my wax will come through. We'll see, but that's what this video is kind of about. You can see the inside of the kiln. It's got 2 1-inch layers of ceramic fiber, a little chimney in the top. The ceramic fiber is awesome stuff. It's inexpensive. It keeps the heat in. You can see that the outside of the furnace has had very little heat damage. The original paint pretty much intact everywhere. I lose a little bit of heat around the corners of the doors. None in the back. So structurally it's good. I get good heat.